Good morning, everybody. I hope you're at least as awake as I am. Right, no laughter, so maybe not. So I would like to talk to you a little bit about IPv6 first data center and about some learnings that we had over the last 2 years. First of all, what is data center light? Data center light is an approach to reuse existing factory halls in Granaland, in Glarus. So the whole idea why it's called light is because we don't rebuild, we don't try to waste energy, we don't try to do things as other people do. Not because it's bad, but because we have had quite a unique situation in Glarus. For the background, those who don't know much about the history of Glarus, Glarus used to be like a very attractive industrial canton featuring a lot of spinning and weaving companies. However, most of them went out of business, but left their power plants in the factory halls there. Well, left. I mean, they're still there and still running. So it's quite an interesting situation. So what we do with it is we use those old factory halls, and we decided to go with a passively cooled data center. Passively cooled as in we use outside air or no outside air at all, because we are featuring walls that are between 80 centimeters and 1.5 meters thick. So when you see our temperature graphs, it's like between, like when we have very strong sunshine, we have something like a difference in 0.5 degrees Celsius during the day. It's quite impressive. Furthermore, like I said, like data center light, we're running completely on water power, which is almost completely true. There's some 10% of solar power in there. Everything is open source, and we say it's 100% IPv6. The main product is virtual machine hosting or infrastructure as a service, just for giving you an overview. So why am I here talking about IPv6? Well, we started in 2017, and you can imagine 2017 is not, you know, it's not 1980s where you only were going with, well, I will just do IPv4 because it's what everybody's doing. Then again, 2017, you all know by yourself, we're still somewhat in the IPv4 world. So when you start a data center in 2017, it's like a question like, what do I do? Do I go IPv6, IPv4, dual stack? What is the smartest thing? Our objective is in the terms that we want to grow towards a couple of thousands VMs. We don't want to grow too much. We don't want to be like anything like Amazon. I want to grow to a certain size. So 1,024 IP addresses, it's not that much if you want to run a data center. So just a short question, like to get some of you awake. Like if you were to build a data center today, if you had to choose between IPv6 or IPv4, what would you choose? Those saying, I would completely build IPv6, can you raise your hand? Well, at least I would say a sixth. Okay, I will not, well, let's do the other check. Who would go solely on IPv4? Oh, less than that. Interesting, very interesting. So when we had to make the decision, we were thinking about it very long, and in the end, it boiled down to that. We were thinking like building a data center on IPv4 is like really building like a diesel car. You can do it, you will sell it, but it's really not pretty, you know? It works, but it's not pretty. So our first approach was, well, we're new, we're in a green field, let's do completely IPv6 only. Completely means every server, every router, every virtual machine by default only has IPv6. We just add IPv4 on the border routers using NAT64. We thought that's a great idea. And because, you know, you just basically go single stack all the way through, and you don't even have to think about IPv4. It's so nice. It's really like clean and like, you know, it's really nice. Then, you know, you're trying to build up a company, a startup, and you actually want to actually sell stuff. So, well, doing that, we figured out obviously using software that listens to 0000, which is the IPv4 any address, well, that fails because there's no IPv4. Luckily, we found out, like in the very first building of the prototype, you can get rid of this. Like you can, like most software nowadays, you can reconfigure. You can just say, listen on IPv6. You can just listen on double point. You can do a lot of things. Most of it can, but there's some software that can't bind on that. Then again, you can use proxies like Nginx or HA proxy to get around this problem. Just bind your like old software to a local host, and you can just proxy it out via service. Having solved that, we had interesting customers coming to us saying, we would like to run this particular software on your hosting, and was like, sure, just go ahead. I mean, it's Linux based, so what's the point? After some time, they came to us and were like, for some reason, we don't have an internet connection. I was like, but you logged into it using SSH, how can you not have an internet connection? Figuring out, like after some debugging, that there's some software, I'm not naming something here, but it's a bigger software written in a Perl bash script used at most hosters for managing with a UI servers that actually does hard code a couple of IPv4 addresses. So all our nice idea of, we go just IPv6 only, we use DNS64, which basically translates requests for hosts that don't have IPv6 into fake IPv6 addresses that are translated by our routers. That will not work if there's no DNS request. So our whole approach, like everything IPv6 only, was like, right, we're not able to get around this without IPv4. So you already read it there. It would have been too nice to be true. And so actually, we went on to stage 2. So just give me a short insight of like how our work looks like there. We're thinking like, what is the future there for us? And indeed, it was a bit dark. We had to go back to IPv4. Basically, as said, we are a startup, and I mean, for any company, it's important like to care about what the customers want. And we obviously wanted to have an IPv6 only system. However, if that's not what the customers want, it doesn't make a lot of sense to build it. So what we did is in stage 2 was we actually changed our approach and said, all right, all the virtual machines that we have for renting out, where the customers are actually running their software on, they will be dual stack from now on. This gave us back like full operability with basically every software without like anything, the customers didn't notice anything anymore. Before, when we were in the IPv6 only area, customers were actually wondering like, where's my IP address? And you might look a bit strange at me, like, now where's the IP address? Well, obviously, if there's only IPv6 on the machine and people are not used to IPv6 addresses, they don't see any address. With this approach, we actually made the customers like feeling home again, like, having IPv4 address there. And in the second stage, what we did, the only hardware with IPv4 is still the routers. Like none of the servers, none of the storage backend, nothing has IPv4. So communication there is all IPv6 only, but the virtual machines are running on IPv4 and IPv6 obviously. So over time, like I said, like we started the project in early 2017. We changed our infrastructure from installed servers to booting the servers via network. Most of you probably know this mechanism. It's called PXE or netboot. Basically, you have your computer not have an operating system installed, but load the operating system over the network. Turns out, this is greatly supported in IPv6. However, not every firmware in your servers fully supports IPv6 netbooting. So at that time, we actually had to introduce a separate boot network so that servers can actually get their operating system. What we do though is after the server is booted, the server itself doesn't care about the IPv4 address, throws it away and stays solely on IPv6. The dual stack VMs so far are running without any problems. However, and then we are coming back to what I said in the beginning, we're a startup, and as a startup you kind of think about like how to make the world a better place. And obviously the world is not a better place by pushing more on IPv4. For us it's clear we can go to the market and we can say like, okay, we'll acquire another /22 or a couple of /24 and just make up our IPv4 pools. But we think this is fundamentally going into the wrong direction, because IPv6 has been there and it is a solution for all of those problems. Clearly we are a bit in the, let's say, in-between time where we still have a lot of systems, let's say IPv4 only, and there are not so many IPv6 only networks. We are running some of them, but eventually the problem here is between our engineering team, which says we want to go as much IPv6 as possible. Basically 0 IPv4 would be the objective. On the other hand, there's a sales team that says we want to sell, and we want to sell, and we do need IPv4 on the VMs. So the question was a bit like how to continue there. Which way should we go down? And I put up this cartoon a bit for you to see like a bit like what is wrong also with IPv4. I don't know how many actually can relate to this. Basically, when you have IPv4, and typical like situation is now that you do network address translation because you don't have enough IPv4. Then you see actually, oh, even like my private IPv4 address space also kind of exhausted because I have overlapping stuff in my networks there. So I do another NAT, and this is just madness. So what we decided to go for is something like an in-between approach. What we're going for is, we call it IPv6 on steroids. And after I would say like our first approach to have IPv6 only VMs, and we kind of decided that our first stage was, let's say, problematic. We then thought, okay, in the first stage we tried to sell generic hosting to people, and we didn't really mention that our infrastructure is IPv6 only, so people were a bit confused. Then we thought, okay, well, why not make it very explicit and say, we do have IPv6 only hosting. You're not going to get an IPv4 address there. Not a private one, not a public one, none, nothing. What does this mean? It basically means we are selling virtual machines that are unreachable from the IPv4 world. Which is, you can argue, well, it's actually nice, like anybody with IPv4, if you want to access it, you should really upgrade. Then again, you and like other customers might also be like thinking, if I run a web server, it would actually quite convenient to be reachable from majority of the internet. And we absolutely agree with that. So before we go there, what we actually see is like, and why we actually push this quite a lot is IPv6 only VMs can help you to understand where we are going to. So we actually we designed like 3 different cases, and first one is obviously development. You want to be able to develop on IPv6 only systems. So you can actually think like, how does my application behave? Is it actually reachable? Will it actually listen on IPv6 as a protocol? That easily works for testing, for putting staging on IPv6 only. That also works perfectly. But what do we do with production systems? Because that's the majority of stuff that's out there. So if I go back to our first stage, what we did there is, in the very first stage, we had a NAT 6.4 and we would have a one-to-one mapping on IPv4 addresses to IPv6 addresses. But that's not really, really helpful. So what we want to have is one-to-n mappings. And now my question is, like, who of you remember when Apache initially introduced vhosts? Like some older people here? Perfect, great. So I see none of you who raised the hand, as far as I can see, did have a gray beard, but you should. For the background, those who didn't raise your hand, in about, must have been around the 90s, I'm not exactly sure, it was around between 1996, maybe 1998-ish, I would say, roughly. When Apache, the web server, you might like it or might not like it, doesn't matter, let's say the web server of the internet did not have support for vhost, especially not for SSL. So basically, whenever you set up a new domain, you would just put another IP address there with IPv4. Not talking IPv6 here, with IPv4. So every time, at least for an SSL host, you would put a new IP address. And this is like really, really wasteful, and no provider could even at that time afford it. So everybody was really happy, like when Apache finally introduced support for vhosts, the HTTP host header was there. This was actually at times when, I think, early HTTP 1.1, because HTTP 1.0, I think, didn't have the host header, if I'm mistaken. So basically what we want Apache vhosts, but for everything. We don't want it only for HTTP, HTTPS. We actually want it for everything. So we began to investigate a bit, like how far can we put this? How far can we go with IPv6 only VMs and still have them fully reachable in the sense of offering services on IPv4? As mentioned, HTTP is generally speaking not a problem at all because you can use the host header there. HTTPS still works. For those who are not much deep into technology, HTTPS, I think most of you know, it is encrypted HTTP. So vhost on it is a bit tricky, but luckily at the moment, TLS 1.2 includes the header in the TLS handshake. So before the full encryption happens, you're actually able to analyze what kind of host the client wants to look at. This will change with, or might change with TLS 1.3, where keys will be stored in DNS later. But I'm not going to talk much about this. So for the moment, HTTP, HTTPS, we have this running that works nicely. And SMTP, well, it's quite easy. You can just like proxy it as in, you can take the email and forward it. So this is also very easy. Same for DNS, where you can do delegation and caching. And originally, when we did NAT 6.4 in our data center, we did, as said, we did one-to-one mappings. And what we're looking at right now is really layer 7 based proxying. So we inspect stuff on the various layers to actually make a decision. A packet arrives for an IPv4 address, how do we actually translate it? So this is how it actually looks up, and this is like now we are at a philosophical problem, and that is, if we are doing HTTPS encrypted proxying, we can either open up the connection and then proxy it. This is the first approach, and then we can actually insert the IP address that originally the IPv4 address that requested the website. Or we don't care and we just do it on TCP basis, but then we also have no possibility to actually inject from where the original request comes from. Right, so that was a first glimpse of like what we're doing in the IPv6 first data center. As said, the whole data center from the very start was built on IPv6. We had like our findings on what not to do only on IPv6 only, but we're very happy to like push now more for IPv6. If you're more interested in this stuff, you can reach out to us at ipv6@ungleich.ch. You can chat with us. You can even hack with us. We're having a hackathon on the 30th of November to 2nd of December in Glarus, where IPv6 will be one of the main topics. And we're working with some people together on an IPv6 blog. So if you are interested in IPv6 and if you're interested in reading or posting stuff, please come to me later, because we're trying to establish there like vendor-neutral IPv6 update blog. And another thing, so my last thing for today, we will establish an IPv6 only freelancer platform, which is kind of, you're actually filtering out those people who are not even able to use IPv6 to get some kind of, you know, basic understanding of what kind of freelancer you're getting there. Right, that's it from my side. Thanks a lot. Hope you enjoyed it.
Thank you very much, Nico. Are there any questions? Okay, hold on. So I go from the front.
Okay, so 2 issues. I do a lot of like similar things for like my own, like a few hundreds VMs for like with IPv6 only addresses, because obviously same issue like I can't afford tons of v4 space. But I run into 2 main problems. One is like access from remote, especially when you're in like third world countries like this one, where none of the mobile provider has v6. So like accessing anything with over v6 only is like very painful. I always have to do a VPN or some other proxy. I'm curious how you resolve that. And the second thing is from the system itself, going out, a lot of like repositories or something still are v4 only, or like GitHub is v4 only. So it's really painful. So I usually have to do at least outbound net for like v4.
Right. Oh yeah, perfect. So, do you hear me?
Yes.
Okay. Okay. So the first one, we're also facing actually with some of our own employees, because we are internationally distributed. Sorry. So what we basically did is we established an SSH jump host that basically anyone can register into. So from our infrastructure, we are using like standard LDAP for user base. So basically anybody who registers into our LDAP actually gets an access to our jump host that is without shell access. So you can only use it to jump in via IPv4 to IPv6. VPN we also tried, but VPN is usually, you know, it's quite cumbersome, and it's like also, it might actually drop routes that you actually want to be able to access to. The second thing, we do actually run NAT64 outgoing on every network, but we also migrated away from GitHub because of that particular issue. Because you're laughing, but the thing is, when you're a startup like us, and when you're fully setting on IPv6, you don't really want to support companies who, after requesting more than 20 times to add IPv6 over more than 2 years, saying no, you don't want to support them anymore. So that's why we actually moved away.
Two questions on your SSL approach. If you don't break it open, will TLS 1.3 work? Because if you have to get an SSL certificate, I think that Let's Encrypt at least prefers IPv6, so only the backend server, the actual server, will get a certificate, but not your proxy. So you cannot get a certificate automatically through Let's Encrypt, because it will always say challenge failed. Been there, done that. And anyone knows what TLS 1.3 will do with that?
Okay, the first case we actually solved. And we're really, really happy to have that one solved. Because yes, in the beginning it was like, because there are now 2 hosts, one IPv4 host, our proxy, and an IPv6 host. I'm very sorry for that. And yes, there are 2 certificates, and it's IPv6 first, which is great. So what we actually do is our clients, they have a rule in their web server to, if there is a request for the challenge of certbot, and there's no file, it will be forwarded back to our proxy. It works. And most funnily, it actually works through IPv6 then. So Let's Encrypt contacts the server via IPv6, connects our proxy indirectly via IPv6. It perfectly works. Yes, so that works. TLS 1.3, as said, it will or might shift keys to DNS, which is, I mean, we will see a very interesting speech later today about automating DNSSEC. So this will become more and more interesting. But for 1.3, we don't have out-of-the-box solution, besides in the end copying the keys, which is not really a nice solution.
Yeah, this is Thomas from Flex Optics. I got a question regarding your stage 2 and stage 3. When I operate a IPv6 only web server and you're set up, how do you enable me as a customer that I can analyze my IPv4 traffic?
Right. So let me go back one slide here. What was it? L? So in the case number 1, when we open actually up HTTPS traffic, we have the possibility to add a header saying x forwarded 4, and then you have actually the IPv4 address of the original request. And this is like a really philosophical problem here. In the end, like as a provider, we don't want to see what you're getting. We don't want to know like what kind of secrets or whatever you're transmitting there. So we actually prefer the second approach. But there, your question comes back, how do you insert that information? And the answer at the moment is you don't. So
okay.
That's a problem that we're working on.
Okay, thank you very much.
Thank you. Any more questions? Coming.
What traffic ratio do you get right now, like IPv4 to IPv6?
I have to say I don't know the up-to-date stats by today, but the last month it is roughly 40-60. Unfortunately, the 40 is IPv6. It's not yet there, but you know, going that direction, trying to do more of that. Yeah.
Thank you very much.